is just equals to 4, negative 6, 12 plus lambda of 1, negative 3, 2, where lambda is a real number, right? For the plane is just where x equals to 0, right? So how do we find the point that satisfies both of them? How do we point? Can anyone describe what's the working? Maybe I ask Praveen. Praveen, can you describe your working? You never do. Okay, I ask Yu Hao. How do you? What's the first step? Can you describe the first step? Equate. What do I equate? You got the gradient of the plane. The Which one do I equate? Sub the r into the vector equation. Okay. So which one do you sub? Into this one. Okay, so some students see this way. So actually there are a lot of variation. One is I can see this is x equals 0. Some students actually see this way. R dot 1, 0, 0 equals to 0. Okay. Some students also see this way. Some students can say that you can say it's x 1x plus 0y plus 0z equals to 0. Okay, and then they actually sub in the equation of the line. Okay, all you can do is you can see if this x equals to 0, right? Over here, can I also say that x equals to 4 plus lambda? Can I say that y is equals to negative 6 minus 3 lambda and z equals to 12 plus 2 lambda? On this side, x equals to 0. So, a lot of times, right, while solving, usually the connector or the linking variable is x, y, z. I always use x, y, z to link. So here I have one x. Here I have one x. Now I can link them together. On one side, x equals to 0. On the other side, x equals to 4 plus lambda. What relationship can you draw? I ask Kaipin. If my point has to fulfill both of them, right, what does it say about lambda? Lambda must be negative 4. Okay, that's a very quick conclusion. So from here, straight away you can see 0 equals to 4 plus lambda. Lambda equals to negative 4. So your point has the parameter lambda equals to negative 4. And from there, very quickly you can sub back in, right? Negative 4. So negative 4. So x equals to 0. Y is equals to negative 6 minus 3 negative 4. Y is equals to anyone? 6. Okay. Z equals to 12 plus 2 times negative 4 equals to 4. And quickly your answer comes out to be 0, 6, 4. Okay, so try again. Proper present, don't leave the answer like that. Okay, so don't leave the answer hanging. So I'll write my answer properly. I will say part 1, the position vector of the point where L meets x equals to 0 is 0, 6, 4. Okay, I know very boring. I write this that you all fall asleep, but this one important. Here, some teachers also tell me. Some teachers already say my practice is not very good, so I must tell you. Okay, so okay. Part 2, xy plane. What does xy plane tell you? Ethan.
That means your position vector.
Okay. After that, right? Very quickly, what can I do? What do I equate? Let me ask family. Family Lim. What do I equate? How do I find the position vector of the point? Very good. So this is what family did, huh? Okay. We equate the z components. Okay. Very quickly, because I know that I can use the z components on. So again, we are using the Cartesian xyz to link us together. the x, y, z can be a linkage. The y can be a linkage. Huh? So this, I take the z component, 0 equals to 12 plus 2 lambda. Lambda equals to -6. Okay, then from there, I find my x. X equals to 4 plus -6 times 1 equals to -2. Y equals to -6 equals to 12. Okay, so final answer. How do I write the final answer? I leave it like that, is it okay? So you must write down, shh, turn, Ignatius. Ignatius, you're always talking. I give lecture, you talk. I give tutorial, you talk. Huh? I'm going to sleep. Okay? Can hor? Can hor? I'll go slow. Listen. Okay. Next one, exact plane. Okay. Hui Yi, what does it mean? Exact plane. It just means y equals to 0. That's all. Okay? It just means y equals to 0. So number 3, y equals to 0. So first plane, y equals to 0. Second one, the line. Okay? So the line again is 4, -6, 12 plus lambda 1, -3, 2. Lambda is the real number. Okay, quickly again, I equate the. What do I equate now? Praveen, who do I equate now? Which component do I equate? Very good. I equate the y components. Okay, 0 equals to -6 minus 3 lambda. Lambda equals to -2. Very good. And from here, you should get your position vector to be 2, 0, 8. Okay, Ken? Yes. 6, 0. Position, probably careless. Then the answer is unique one. Cannot have a scalar multiple. Because we are talking about position vectors, okay, so it won't be a scalar multiple, actually a unique answer. Okay? Can Question 4 is hard, so question 4 I go slow. With a position vector of 1, 3, -4, and a point B with a position vector of -12, 8, and 4. Okay, so this one very quickly. -12, 8, and 4. With respect to the origin. 1, 3, -4, respect to the origin. The point P is on the line OA. The points Q and R are such that PQ equals to 1/3 of QB and OR equals to 5 Q. So, oh my god, what a handful. Oh, okay. So, such a long question. What do we do? What's the first thing you can do? Write out everything. It's written there for you. What's the first thing you can do? Draw. Correct? Right. When you're young, what's the thing you like to do? You like to draw. When you're old, it's the same. You still draw. Okay? First one. Point A and point B. This is the first thing that comes to us, right? So, since they gave this out to us first, let's draw it. Point A and B. Okay, so this could be 1, 3, -4. B could be somewhere here. -12, 8, and 4. Okay? The point P is on the line OA. So what do? I just draw. P may be somewhere here. Okay, lies on the line OA. Okay? After that, the points Q and R are such that PQ equals to 1/3 of QB. PQ, so I have P, I have B. 1/3 of QB. If they tell me PQ equals to 1/3 of QB, it means what? Both are actually what kind of vector? Direction or position? Direction. That means from these two, what can I say? They have the same. They have the same position. The same direction, right? So they say same direction, right? Same direction. Shut up, Ignatius. Stop talking. Okay, as long as you catch your attention, I'll do. So I can say the same direction, right? So PQ, QB, same direction. On top of that, they have one common point, right? What does it mean? P, Q, B. Same line, right? Correct? Can say that? Can say that, right? Oh, so this is what they mean. So P, so how do I put? Maybe somewhere here. Can, right? And the ratio here is 1:3. Can? After that, OR equals to 5 times of OQ. How to draw? Damn long line. Yes, very good. I like what Kevin say. 1, 2, 3, 4. Okay, so for example, damn long line. OR is here. Can? That's all. That's all. Then after that,
Not that they're actually on the same line. Doesn't it just mean that the PQ and QB is parallel?
PQ and QB is parallel. On top of that, PQ, QB. So means what? They have a common point. They have a common point. So by this itself, you can see that they have the same direction because they are scalar multiple of each other. So you can see that actually they are the same direction. On top of that, they have a common point. So same direction and one common point, same line, collinear. Can, right? Okay, so if I show you, I tell you this AB equals to lambda or BC. ABC is collinear. They are collinear. Okay, Since they are scalar multiple, on top of that, they have a common point. Okay, so after that, next, show that R is on the line whose vector equation is negative 15, 10. So I want to show that R is negative 15, 10. Who managed to do this? Who managed to do this? Part 1? Family do? Family can do. You how? What you do? Very good. Okay, that means you all at least you bother to watch. Which is good. Okay, I like the attitude. Okay, so Peter here is not an argument. It's just a. Okay, Then from here, right? Simply, what do I mean by R lying on the line? Can anyone describe to me? When I ask you to show that this point lies on the line, what do I mean? What do I actually want you to do? So there's a value defined. For example, y equals to x plus 2. Show, maybe 3x plus 2. Show that what common 5 lies on the line. This is your line. Can, right? So what does it mean by? It means that your coordinates take the form of the equation for some value. It takes the form of the equation. Okay? So here I want to show that the point takes the form of the equation. Okay? Takes the form of the equation. From here, R is on the line, vector equation. Okay, so very quickly, then we look at our question. Then we see, R. How do I find R? What is R connected to? Stop looking at metals. If it drops, let it be. Kaipin, Benjamin, family, look here. Your 3, wow, really. How do I, what gives me the hint to R? What gives me the hint to R? Who is connected to R? Q, right? Can you see? So, likely that means, okay, I need to find R. That means, if I need to find OR, what do I need? I need OQ, okay. So now I need to find OQ. I look at OQ, okay, I want to find OR. So step 2, I want to find OQ. If I want to find OQ, can I find OQ? Who do I need? Come again? OP and OB. Okay, so Monisha, Kiho say to find OQ, right? To find OQ, Kiho says to find OQ, he uses OP and OB. Okay, Praveen, do you know why? Very good, we use ratio theorem. Okay, every time when you see a fraction, what do you suspect? Ratio theorem. You see, a fraction is a ratio, correct? A ratio. Okay, so actually you suspect ratio theorem. So here, say again, to need OQ, you need OP and OB. And then you use ratio theorem. Alright, so that is the thinking process. That's the thinking process. Okay, so we must be comfortable with handling long questions like this. Okay. So I want to find OR. Okay, I need to find OQ. To find OQ, I need OP. So to find OP, do I need anything? What is OP? OP is just a part of OA. So can I just call it anyone? What can I call it as? Maybe I just call it a lambda OA. Can lambda OA. Can huh? OP equals to lambda OA. Right? So very quickly, we using ratio theorem, right? Using ratio theorem, okay, OQ is the same as OB, 1 of OB plus 3 times of OP divided by 4, based on this diagram. Can you see? Okay. Can you see based on this diagram? Anyone cannot visualize? Anyone cannot visualize? Okay, so you see, OP is here, right? P, O, Q is here, right? B is here. This one is your Q. 1, 3. Can you see? So this one is like the OP. This one is OB. Can you see? So this part ratio theorem. So ratio theorem we cross here to here, here to here. Yeah. This way. Okay. So you can see that OQ. Can see? Rongshan can see. Ratio theorem, don't tell me you don't know. Okay, you see a fraction straight must use ratio theorem. Okay, don't die already. No, okay. This time the test really not difficult. Okay, if really you all must really do well for this test. Okay, it's supposed to be a morale booster. Okay, OB OB is what? OB is given is -3, 2, 4. OP, as we know that OP is just a 3. OP, right, as found is over here. The OP is here. Right, so it's just 3 of lambda OA. OA is 1, 3, -4, right? So this is OA. OA is 1, 3, -4. So I erase away 1, 3, -4 divided by 4. Answer comes out. You should have -1/4 -324. Okay. Okay, so that's your OQ. Oh, sorry, OB is wrong. Yeah. OB is -12, 8, and 4. Okay? So from here, you have 1/4 of -12, 8, and 4 plus 3 lambda over 4, 1, 3, -4. Then 1/4 of -12, 8, and 4, you can just write. This is just becomes, you can see it will cancel off by just -3, 2, and 1. 3 lambda over 4, we can just say let maybe mu be equals to 3 lambda over 4. So this one will become mu 1, 3, -4. Okay? And so understand how to do questions like this. If it lies on the line, means you must take the form of the line. To find OR, I need OQ. To find OQ, I need ratio theorem. Okay, you are expected to be able to do this. So think back how everything actually linked very logically together. What the question asks you to find, the question will provide you bridges to get back to link the questions together. So this is your OQ. Okay, after that, given OQ, how do I find OR? I just times 5, okay? Can so this is your answer. Given OR is just equals to 5 times of OQ. Alright, so it's just equals to 5 times of your OQ is your -3, 2, 1 plus mu of 1, 3, -4. Okay, so from here, I just bring the 5. That's all. bring the 5. Very easy. So 5, negative 3, negative 15. 5 to 2, I have 10. 5 to 1, I have 5. Da-da-da-da. Come out already. 5 to mu, so-called 5 mu now. 1, 3, negative 4. Okay, you go back to the question. Look at this, children. Look at this. You go back to the question. 到了咯. We are there already. Okay, we have reached the stop. Oh, so if you find OR, right, where I want to say that it lies on the line, right, I can also say that I want OR to take the form of the equation of that line. So I want to show that OR can be in this form. So if it's in this form, and it's also the equation of the line, I can say that OR lies on the line. I have a
even a part of the line is the same equation.
Even a part of the line has the same equation. So for example, this is my line, right? So R equals to plus lambda or maybe 274. 274, something like that. Okay? Where lambda is a real number. I want to show that I want to show that 3, 9, 7 lies on L. I want to show this. Right? So how do I show? I can show that if I can show that it takes the form of the line, right? It can, right? For what case lambda is just equals to 1. So I can say, actually this lies on L because it takes the form of the line for some lambda. Here, right, the problem is we don't know what is theta. Because there's a bit of ambiguity. Hey, Ravi, you sleep! Like that. Talking to your head. Which head are you? Okay, so you must show that the last of the line so that it actually fulfills the equation of the line. That's the idea. But here, right, the theta is not clear. Right, but this is the equation of the line. If I can show that my point, right, can be in this form, means it lies on the line. Okay. Any questions so far? So that's why you see, just now I asked you, what does it mean by showing that R lies on the line? What do I mean? It means it can take that form, it can take the template equation of the line for some lambda, for some theta. So here we don't know what's the theta, but we can show that actually R can be in this form. So you can see, now we come back to this question, right? Can you see? From here, you can say that actually OR is just equals to negative 15, 10, 5 plus maybe plus theta 1, 3, negative 4. Where your theta is equals to 5 mu, okay? Can. If you are going to use a new variable, please state what's the new variable. Okay, don't just use lambda for everything. Okay, don't just use lambda for everything. That's a common error. Okay? Okay, so understand what I mean when I say show that the point lies on the line. It means it can take the form of the line. Okay, part 2. The plane P contains a line and is parallel to 11, 7, 8. Okay, the line through A perpendicular to P meets P at L. Now what do I mean? Okay, so the P, your plane contains the line L. So your L lies on this line. So this is your line. The line is just nothing but negative 15, 10, 5 plus theta 1, 3, negative 4. Right? So this is your line. On top of that, it is parallel to 11, 7, 8. Parallel means what? Does a vector need to lie on the plane? Don't need, it can be floating in space as long as it's parallel. So 11, 7, 8 could be somewhere on top, floating in space. 11, 7, 8. It's a direction vector floating in space. The line through A, right? The line through A, so A is on top, probably somewhere here. This is A. Perpendicular to P, so maybe somewhere here. Meets P at L. Perpendicular, so meaning that here, right? This portion, this one is 90 degrees, it's perpendicular. Okay? So AL is perpendicular to the plane. Right? Find the position vector of L. How do we go about doing this? Stay with me. Okay, I know this one a bit dry, so a bit boring. Okay, the second part, which the green part. Okay, very good. So here, right, find the line through A. A is on top. A is 1, 3, negative 4. I will describe as I show. Okay, the line through A perpendicular to P meets P at L. So meets P at L. So this is L. This is your plane P meets P at L. Okay. Here, find the position vector of P. Alright. First thing we can. Okay. So how do we go about doing this? Very simple. Okay, children. This is under the topic intersection between the okay, what we call the foot of the perpendicular. Okay. I give you a plane. I give you a point. Okay. 1, 3, negative 4. How do we find? How to find foot of the perpendicular from the point to the plane? Anyone? Show me some starting point. Show me a starting point. You just try. It's okay. Don't worry. Just try. Okay, I want to find this point. Okay, I say again, I want to find this point. How to find this point? This is the foot of the perpendicular. This is point A. Very good. Find the normal. How do I find the normal? Okay, normal vector. Given that here at L, how do I find the normal vector for this plane? Very good. So here there's a line L just now, right? Line L, right? The direction vector of line L is 1, 3, negative 4. Very good. Any more? The other vector, because they say it's parallel to 11, 7, 8. So using these two, right? Using okay, let's say I call it M1, M2, right? Right? Using M1 and M2. This is the general idea. Find the normal vector. What is the purpose of finding the normal vector? Can I ask anyone? What is the purpose of finding the normal vector? Migalaba. Why do I find the normal vector? The position before that. Why do I find the normal vector? Very good. Because N gives the direction vector of L. Or direction vector of AL. After I have the direction vector of AL, what's my next step? What do? I produce the equation. I get the equation of AL. Then after that I can intersect it. So after I have the equation of the line, the equation of the plane, then I can solve. Yes. I can put it because it's parallel. I can just put it on the plane just to show. These two. Right. Which one again? Parallel to the plane. Parallel to the plane. Then you see the parallel to the plane. Okay, so not easy, Okay, I'll continue this again next week. Okay, I know. Okay, but if you are interested, you can follow the test. Okay, can.